Today we discuss about introduction to electrical machines. Okay. Before going to the discussion for electrical machine, first we have to understand what is meant by machine. So machine can be simply we can define as if a work is progressed. So what are the equipments we are using? That simply we are called as a machinery. So what is the major advantage with the machinery? So it will be simplified the human work efforts. So for example, for the harvesting purpose, in the olden days they are using the mans for cutting and carrying. So all the purpose the humans will be made the work. But then after, nowadays we can see here, the harvesters will be implemented to do the work instead of the human beings. So that will be simplify the work, at the same time it will be minimize the cost of production as well as operations. That is a major advantage of the machine. So in case of electrical machines, here also the same concept will be used here. So what are the operations will be performed? So what are the functions will be performed? Those are all things will be minimized by means of electrical machines. So this is the introduction to the electrical machines concept. So electrical machines again further classified into two types, AC machines and second one is the DC machines. So why it will be classified as a AC and DC? If the machines will be work for DC supply, that is will be called as DC machines. And second one, if the machines is working for AC supply, simply that is we are called as a DC machines. So here in case of electrical engineering, the machine can be defined as to simplify the work, at the same time it will be progress the work. So here in electrical engineering, the term of machine can be used as first one is a motor, second one is a generator. Right? So in case of AC as well as DC, the machines can be classified into majorly two categories. One is a motor, second one is a generators. For example, if the machine is convert electrical energy into mechanical energy, simply those will be called as a motors. Similarly, if a machine is convert mechanical energy into electrical energy, simply those will be called as a generators. So we can understand, so we cannot produce the energy, we cannot destroy the energy, but we can convert the energy from one form to another form. That the basic principle we can use here in case of the machines also. So here in case of motor concept, the electrical energy will be converted into mechanical. In case of generators, the mechanical energy is converted into electrical energy. So this is a common concept we are using for DC machines as well as the AC machines. So according to the construction, there are different classifications is there. For example, in case of AC machines, there are two type of machines will be we have. One is a asynchronous machines, second one is a synchronous machines. Based on the speed application. For example, if the speed of the machine is approximately 1500 RPM, so those simply we are called as a synchronous machines. For example, if the speed is less than 1500 RPM, those will be called as a asynchronous machines. So here, in case of synchronous machine, mostly those are the double excited machines. But in case of asynchronous machine, mostly those are only the singly excited machines. For example, induction motors. Induction motors will be we are called as a asynchronous motors. Synchronous motors again further classified into two categories. One is alternators and second one is synchronous motors. These are the basic classifications of the synchronous machines. So for example, if it is producing alternating current, acting as a generator, simply those will be called as alternators. If it is producing the mechanical energy and the speed of the machine will be remains constant at 1500 rpm, so those will be called as a synchronous motors. Similarly, in case of asynchronous machine, so simply they are called as a induction motors. Induction motors is further classified into two types. One is a single phase and second one is a three phase. This is based on the supply only we are discussing. So let again the three phase induction motors is further classified into two categories. One is a squirrel cage induction motor, second one is a slipping induction motor. So this is a tree of AC machines. One is belongs to synchronous machines and second one is belongs to the asynchronous machines. These are the basic classifications of the AC machines. So in this semester we are discussing about AC machines. So first we can understand the concept of asynchronous machines and synchronous machines. First we discuss about the synchronous machine, then after we go for the asynchronous machines. So this is a introduction related to the AC motors. So next we are discuss about DC machines. If the machine will be work with DC, that is simply we are called as a DC machines. Here the DC machines is further classified into two categories. One is a permanent magnet DC machines and second one electromagnet. One is a permanent magnet DC machines, second one is a electromagnetic DC machines. So what is the difference between permanent magnet and electromagnet? So from the raw material what are the electromagnets is made. So if those will be using for the excitation purpose, that is will be called as a permanent magnet DC motor. Mostly the size of the machines will be very smaller. For example, we can use motors for the driving of toys, small toys and robotic applications. Generally permanent magnet DC motors will be used. And second one is electromagnets. The name itself says whenever the electrical energy is flowing through the material, then they are acting as a magnets. When they are disconnected from the supply, they are losing their magnetic properties. So that's why it will be called as a electromagnets, or it is also we are called as a temporary magnets. But why we are using mostly electromagnets in such applications? Because whenever the permanent magnet DC motors we are used or magnets will be used, when the capacity is increases, automatically the size of the machine also increases. And second one, cost of the machine also increases. When size increases, automatically the magnetic properties of this material becomes reduces. Due to this reason, mostly this type of materials we are not used for medium and large scale applications. Only they are preferred for small scale applications only. Next, second one, electromagnets. What is the major advantage of the electromagnet? With a small cross section area, we can produce bulk amount of magnetic field. That is a major advantage with the electromagnets. That's why mostly 90% of applications is made by means of electromagnets. So here, based on the electromagnets, they are further classified into two types. One is the self-excited, second one is the separately excited. So these are the basic two classifications. Then again, self is further classified into three types: series, and second one is a shunt, and third one is a compound. So these are the basic classifications of the DC machines. For example, if there are field excitation will be separately, that will be we are called as a separately excited machine. Any machine will be consisting of DC machines, two parts. One is a field winding, second one is a armature winding. If the field winding is separately excited by means of an external source, such type of machines will be called as a separately excited DC machines. And second one, self-excited.